Hello, I'm Mohammad Nasir Hussain, 19EC010047. This is the video report for experiment number 4 in Signals and Systems Laboratory. The aim of this experiment is to write a code for a MATLAB function to perform linear convolution and to identify the impulse response of LTI discrete time systems with zero initial conditions. So first, what is convolution? So convolution is nothing but a mathematical operation. For an LTI system, the convolution of the input signal with the unit impulse response of the system gives us the output signal. So what is unit impulse response? A unit impulse response is nothing but the output to a system when the input is an impulse signal, that is delta function. So we are given these four systems. These are discrete time LTI systems, and we are asked to find the impulse response for these four systems. The impulse response to these four systems is nothing but when you replace x of n with delta n, you get h of n, which is nothing but the impulse response to these systems. So for this first system, you can observe that the value of h of n will be 1 by 3 for n equal to 0, 1 and 2, and 0 everywhere else. Now for this second system, you can observe that the value of the impulse response will be 1 by m for n equal to 0 to m minus 1 and 0 everywhere else. Now similarly for this third system, you can see that the impulse response will take value 1 at n equal to 0 and minus 1 at n equal to 1. And for this fourth system, the value of the impulse response will be 1 by 2 at n equal to 0 and minus 1 by 2 at n equal to 2 and 0 everywhere else. So this is how the impulse response for the four systems will look like. So now I'll show you the code for convolution. So this is the function that I've written to find out the convolution of two signals. It takes two input parameters, which is nothing but the input signal x and the impulse response h. First we find the number of samples in x, number of non-zero samples, and number of non-zero samples in h. So then the number of samples in y will be nothing but n1 plus n2 minus 1. Next we do zero padding to the input signal and the impulse response signal, and then we find out the convolution of x and h in using these two nested loops. Next in the next question, we are given four real world signals, which include two PPG signals, one ECG signal, and one speech signal. These are the four signals that I've loaded over here. They are stored in the workspace as with these names x3, x4, x2, and xb2. So now I'll be plotting these four signals. So this is how the four signals look. This is the plot for the four signals. In the next part, we are asked to sketch the output of these four signals when they're passed through these four systems. So for this, what I'll be doing is I'll be loading these four signals. These will be the input signals, and for each system I know the impulse response. So to find out the output of the four signals for this system, I'll be convolving the input signals with the impulse response of that system. So these are the output signals for system 1. Similarly, this is for system 2, system 3, and system 4. And now I'll be plotting these four signals here. Plotting the signals over here, output signals. So this is the output of x4 for the systems 1, 2, 3, and 4 respectively. Similarly, these are the outputs for the input signal x3. These are the output for input signal x3, and these are the outputs for input signal xb2. Now if you observe closely over here, this is the input signal xb2, and this is the output signal of xb2 when they are passed through systems S1, system 1 and system 2, and this is the output for system 3 and system 4. If you observe, for system 1 and 2 only the low frequency components are passed, and in system 3 and 4 only the high frequency components are passed. So This is what is asked in the next part. In the next part, what they've asked us is, based on the results of the output signals that we observed, they asked us to describe the function of these systems. So this is the equation for the first system. So based on the observations, we can say that the system 1 is a low pass filter and a moving average filter. Similarly, even the system 2 can be said to be a low pass filter and a moving average filter. And systems 3 and 4 are nothing but high pass filters and differencing systems. Now, in the next part of the question, we are asked to write the code for removing the trend line of an input signal. So I've loaded an input signal over here, XB2. This is the, so the system that I've used for removing the trend line is this is nothing but the system 2. This can be rewritten in this form. This is nothing but the system 2. I've chosen M to be 100 over here. So by doing that, I know the impulse response to the system and I have the input signal over here. So I'll be performing convolution to find the output to the system. The output signal will be nothing but the equation to the trend line. So what I'll be plotting is the input signal minus the trend line equation. So as you can see, this is the initial signal with the trend line, and this is the signal without the trend line after trend line removal has been performed. And now in the last part, we are asked to mention the properties of the systems. So this is the equation for system 1. So as you can see, the system 1 is linear and time invariant. So that is the reason why we are performing convolution in the first place. And we can see that the system has a memory. This is because, as you can see, the current output depends on past inputs as well. So we can say it has a memory. We can say the system is causal because it only depends on, because the current output only depends on current and past inputs. It does not depend on future inputs. And also we can say that the system is BIVO stable, which is bounded input bounded output stable. Similarly, system 2 is also an LTI system. It is also a memory system, a causal system, and a BIVO stable system. In a similar way, even systems 3 and 4 are LTI. They have memory, they are causal, and they are BIVO stable. If you want to say more about the systems, we can also say that all these 4 systems are FIR systems, that is finite impulse response systems. So thank you.